Today I'm working on some interesting experiments with cantilever design. I have set up a 4-story, 4-bay building frame with 2 of the bays cantilevered. I'll be testing 4 different cantilever framings, comparing the results and explaining how it all works, so stay tuned. Before we jump into the experiments, we need to stabilize our building frame. With these long cantilevers, the back column line will experience tension and could lift off the table. To prevent that, I'm using a ratchet strap to secure it down and stop it from moving up. Now on the back span, we have added green cross bracings to serve as the frame's lateral force resisting system. While bracings typically resist lateral forces from winds or earthquakes, they'll also resist the horizontal forces generated from resolving the vertical loads of the multi-story cantilevers. Alright, let's jump into experiment number 1. I'm applying a load to the end of the cantilever by pushing down from both the top and bottom. It didn't take much for the cantilevered floor beams to fail under the significant bending moment. They quickly formed a mechanism, meaning the joints originally assumed to resist the moment with glue started rotating without any stiffness. This signals a failure in the moment connected beams or their end connections. For the new experiment, I'm adding 2 diagonal braces at the lowest level of the cantilevered floors. These braces will serve as a single-story transfer system, redirecting the loads back to the back span. However, there's one catch. In real design scenarios, structural engineers typically extend these braces to connect with laterally stiff elements. For this experiment, I'll leave the back span bay as it is, allowing us to observe how the cantilever moment converts to tension and compression in the beams, transferring the load back to the cross bracings. In this case, compared to the previous experiment without braces, I had to apply significantly more load to observe noticeable deformation. Some of the deformation I noticed is in this area, where the beam is experiencing compression due to the decoupling of the cantilever moment. As you can see from the load path, each brace pulls the load back in tension, bringing it closer to the support. This new configuration is similar to the previous experiment, but instead of a single-story brace, it extends over 3 stories without connecting to the intermediate levels. By doing so, there's a higher lever arm for the cantilever moment, and hence the system may provide higher stiffness. As you can see, the back span beams on these 2 floors are forming the coupling action. The load path in this case is somewhat similar to the previous experiment, with the difference being that the topmost floor beam is now engaging in tension rather than the lower one. For our final experiment, I'll combine the framings from experiments 2 and 3. While experiment 2 had 1 row of braces and experiment 3 extended that row over 3 levels, this time I'll add a brace to each span of the cantilever to increase the stiffness. From the axial load diagram, you can see that in this experiment compared to the previous ones, beams at multiple floors are engaged in decoupling the cantilever moment. Another interesting observation in the studies is that the lateral braces located below the cantilevered floors are not engaged in resisting the horizontal loads induced by the cantilever, as these forces are self-balanced within those levels. Now, the moment everyone has been waiting for. Let's rank the worst and the best performers regarding their vertical cantilever stiffness, starting with the worst performer. The moment frame scenario. Clearly, this case had no bracing and stood no chance of competing with other experiments. And the winner is experiment number 4. As mentioned earlier, this experiment featured braces at all 3 levels and at every single cantilevered span, resulting in a high lever arm for decoupling the cantilever moment and engaging more elements at intermediate floors. Please note that there are many other ways to frame a multi-story cantilever in a building that were not covered in this video. Until the next time, goodbye.